So, hello guys, my name is Ganesh Tiwari. I'm a Chainlink community advocate from Mumbai, and this video I'm recording to talk about something known as Chainlink's off-chain reporting protocol. So now, if you don't know about that, what it is, then this video might help you understand what it is and why is it important for you to understand about it. So let's get started. So, in order for me to talk about this for more than a long time and you to be interested in it, you should understand why it is used. So, as you know, Chainlink is a Oracle network, and it provides you with various data feeds and various different functions to make your smart contracts more actually smart and get data from outside of the blockchain, which may not be easily accessible to them without the help of an oracle. So in this process of giving that data to your smart contract, there is a whole lot of engineering that comes forward in doing that. And the main part, or the main meat of all of this, is their decentralized oracle network. Now, if you don't know what is a decentralized oracle network, let me explain it to you. Decentralized oracle network is nothing but a network of nodes or machines that are running Chainlink's software, or what they call as a Chainlink node on that machine, and that machine can be called as an oracle or a node, and a bunch of them, when ran together to perform a specific task, they are known as a part of a decentralized oracle network, or a DON. Now, when all of these machines come together to do a particular task, there should be some protocol which they are there to, and which they follow in order to you know do any task as they would need to. So the protocol which they follow, or try to follow to become a good node or a good oracle, is known as Chainlink's off-chain reporting protocol. Now this protocol defines a ton of things, how a node should run, or how it is designed to run, so that it regularly completes its task, that is of giving data back to Ethereum, and regularly calculating that data, or doing whatever it needs to. So this protocol defines that. It's a good enough introduction, I think so. So I should get to the source of it. Yeah, so I have this blog, or a document that I am reading. You can basically search this and read it to yourself, but yeah, I'm going to try to explain this to you. So this protocol, yeah, it has some design goals: that it should be resilient towards attacks, it should be simple enough for anyone to understand, it should make sure that the cost in doing all of the things that I had mentioned earlier, it remains less, because as you know, Ethereum is an inflationary, or you could say very costly blockchain, and if you do unnecessary transaction on it, it can get very not beneficial very quickly. So this protocol takes care of that. It should be low latency. Majority of the people using such oracle things in their products are DeFi protocols, and these protocols rely upon having the latest data in order to maximize their profits. So the protocol which gives them the data should have the latest results. So low latency, that is needed. And yeah, The model of this protocol depends upon something known as oracles, or as we earlier talked about, you can call them nodes, and they talk to each other, perform certain tasks that they need to, and then after performing all of those tasks together, if everything went well, a report, or you can say an output, is generated after every set period of time or after certain condition might occur. And this report, when generated and when there is a good time, it is sent back to the smart contract on the chain, that is Ethereum, and that is being used by other people. So that is it. Yeah, this, as we told earlier, this protocol takes care of, you know, failures. So failures as defined in this document are of two types. The first type is a Byzantine failure. So this failure is the typical failure that you need to be worried about. This is something which happens when an adversary takes control of your node and tries to do something bad potentially, and this type of failure is handled in this document. Basically what they do, if they find some node is a Byzantine faulty node, then they basically just don't include that node in the rest of the epoch. Okay, and they don't include any of the entries that are given by that Byzantine faulty node, and that is how they deal with it. And the second type of faulty node is what is known as a benign fault. So this is more of a general fault. So this can happen to anyone, right? Like if your network goes down, or some of your resources on your node were fully utilized and your process was blocked somehow. So this is just naturally occurring faults and you don't need to be worried about it. And this type of fault is handled by like the protocol, in the sense like if a node was supposed to be a benign fault node, then it will quickly recover, and as soon as it recovers, it will follow the chain again through all the messages that are being passed around, and as soon as it is recovered, it can join the chain again and start contributing to the network again. And yeah, in all of these things, like in covering all of these faults and everything, it is essential that the number of nodes which are at fault at any given period of time is less than n divided by 3, where n is like the total number of nodes in Oracle network. So as long as not more than 1/3 of the nodes are faulty, the Oracle will continue working, it will be effective, and it will produce correct results. If more than 1/3 of the nodes are faulty, then you have a faulty Oracle network and you need to do something about it. So that's one thing. And the third part, yeah, so along with all of this, when Oracle network works and it does some calculation, it sends what I told you, a report to something that lives on a blockchain. So in particularly, this is mostly a smart contract, and I have this tab over here where you can see that there are many different price feeds, and all of which are nothing but a smart contract which store all of the data. So whenever a node, decentralized Oracle network, which is responsible for getting this data, they basically send it to this smart contract, and that smart contract takes care of making sure that data is available for all of the consumers. Yeah, basically, yeah. And what's the next? Now, before we talk about anything else, I think it's important that we talk about how these, algorithms or instance of protocols talk to each other. Because in a decentralized Oracle network, obviously there will be many nodes. They need to talk to each other to invoke certain events, and also within a node itself they need to invoke events to proceed further. Like if a leader wants all of the nodes to execute some observation, then you know that has to happen. And if a node itself has observed something and if you want to kick off the next algorithm, it has to do something. So how that is done. So these communication are of two types, broadly speaking. If the communication is supposed to be between nodes, then this happens using something known as sending messages. So if let's say a protocol instance is of type leader and it wants to invoke a request across all of the nodes, then it will send a broadcast message, or you could say a message that is of type broadcast, because messages are also of two type. Like I can send an oracle can send a message to a particular oracle, that will be a direct message, and then an oracle can send a message to all of the other oracle, that will be a broadcast message. So in this case, if I'm a leader and I want everyone to execute something, I will send a broadcast message to all of them. And if in the second case, if I am some protocol instance and I want to proceed further or log something, I will invoke what is known as an event, and this event will be inside my node, and only other protocol instances which are inside my node would know about it or would act on it. That's it. Next part. Yeah, here, and yeah, let's talk about like technical details. So this whole protocol, or you can say the whole description of protocol, is mainly divided into three parts. So these three parts are nothing but the pacemaker, the report generation part, and then there is a transmission part. And all of these three parts are further divided into 5 algorithms. So the first algorithm is nothing but the pacemaker algorithm. So pacemaker runs the pacemaker algorithm. Then algorithm from 2 to 4 are part of known as report generation protocol. And then the fifth and the very last algorithm is nothing but the transmission algorithm. So I will try to explain everything and make sure that you understand. So what is this pacemaker protocol all about? This pacemaker protocol is nothing but a protocol which drives the whole process. So it sets the pace, as its name says, it sets the pace. It creates a new before that, let's talk about something, two terms which need to be understood. So all of these reports, and when they are sent, they are not sent like sporadically. There is some mechanism behind it that determines whether they are being sent or not. So all of these, when nodes are running, they are all in a specific time. There is a leader which is the leader of all of the nodes, and this leader changes from time to time, and the period for which a leader is a leader is known as an epoch. Okay, and in each epoch there can be multiple rounds, and in each round a report would be generated, and the leader who is responsible for generating that report checks whether the report is correct or not. If it is correct and it satisfies all of the conditions, then the report is sent to the smart contract. So the pacemaker protocol makes sure that when it is necessary, a new epoch is generated, there is a new leader elected to drive the whole process, and it also takes care of checking through progress, and checks whether the progress within a particular round or epoch is, according to the needs, and if it is not, then the leader is terminated along with the epoch, and a new process is generated with a new leader so that the report can be sent. So basically, pacemaker protocol is like a monitor, class monitor. It takes care of making sure that a report is correctly generated in every epoch and round, and it is being done very well. It does this using various different timers and progress reports, and by reading all of the messages that are being passed around in the decentralized Oracle network. And yeah, that's a very good explanation to that. And the second part is nothing but the report generation protocol or report generation algorithm. So this is which is initiated by the pacemaker protocol. So whenever the pacemaker protocol decides that yes, it is time for a new epoch to start, and there should be a new leader or and a new round, so it generally starts a new epoch, elects a new leader, and starts a new instance of report generation protocol. So this protocol, as we earlier talked about, it follows the algorithm from 2 to 4, and we are going to talk about them in more detail. But what it does in all of these three algorithms is basically requests all the nodes to observe something. This observation is nothing but what the oracles are supposed to record. So let's say if this instance is supposed to get ETH USD price, so this observe thing will observe ETH USD price in whatever way they do. And after this observation is done, this observation is it's signed and shared with all of the other nodes. All of the other nodes verify whether all of the observations which were recorded were correct or not. If it were correct, then what do you know yeah, there is a very good explanation here. Just see. Yeah, there is a diagram. It's basically explained. Yeah. So an observe request is sent. All of the nodes observe something, and after observing, all of the observations are sent back again, and the leader basically verifies everything, and after verifying, basically it starts a grace period. Like the leader waits for a response for a particular time, and if the responses, all the responses which arrive in correct time, they are automatically included. If they are not, then leader gives like a grace period, and in that grace period the oracles can still submit a report so that they get some reward from it. And once that grace period is done, the leader says, okay, I have all the reports that are necessary, and then it sends a report request in which it consists of all the observation by all of the things, or all of the oracle networks, and all of the nodes independently each other verify each other's observations and see whether all of the observations which were observed by other oracles are correct or not, or they have their particular signature on them or not. If they all and if they all find it all correct, then they all individually sort all the requests, all the reports, and then send it back again to the leader. And when the leader receives all of us assembled final report, it's basically again for forwards it to all the followers again follow all the broadcast it to each other. And once, yeah, so this final echo thing is basically nothing but, whenever a node receives that, final echo, it basically node thinks that, all of the nodes oracles have done the observation thing, and this is a report, it is signed by everyone, now everyone knows. So basically they just tell each other that this this round is complete and observations, all of them were included. And once uh, like yeah, once all of the nodes know that a round has ended, they verify each other and then they send it back to the leader, and as soon as the leader receives it, it says, okay, now it's, I think all of the nodes know that the entire process is done. Now we can move forward to, the transmission protocol. Transmission protocol nothing but receives this, transmission from all of the oracles, and it basically sends the transaction to the smart contract. So that is all this protocol defines, and I can show you an example basically here. So here, if you see this, if you go to data.chain.link, and you can click on any of this, you can see all of the things that I have mentioned. You can see it here that there are 31 oracles here, and you can see that minimum of 21. So as long as 21 oracles are correct and they are working fine, the response, that is answer that is available here, it should be safe and secure and correctly verified. And then there is something known as a heartbeat. So this heartbeat is nothing but a duration of time after which a report should be sent. So here you can see that heartbeat is 46 minutes next. So as far as I know, if I click on this and open this, read the smart contract and get the latest round data, you can see that it was, you can see here that heartbeat is still 45 minutes. And if I copy this, and I already have this, and I paste it here and convert this, you can see that this last report which was generated was 14 minutes ago. And if you see here, heartbeat is still 45 minutes. So I think every 1 hour this report is updated. If every 1 hour, or if the deviation changes more than 0.5%. So in each rounds, in each epoch, these oracles or nodes, they keep on checking the data, and they see, and so here in this round, where in this you can see here in this should report function, you can see that it basically checks whether the timestamp that this current timestamp versus the delta C, that whether the heartbeat has passed or not. If the heartbeat has passed, or whether the value that is currently recorded and the previous recorded, like the standard deviation between them is greater than alpha, which in this case, here it is 0.5%. So if one of this condition is true, so this should report function will pass, and if it passes, then a report will be generated and it will be sent to the smart contract. So I think I can go again here. That is basically all of it that I wanted to talk about. I had done a lot of preparation for it, so if you thought that this video was helpful, or maybe I should deep dive a little bit more on something else, do let me know in the comments or like the video. I appreciate it, and let's see you in the next one. Bye. What I also wanted to tell is I will include an image about this whole, diagram that I have made, an explanation, and put it in the description. So if someone wants to check it themselves, they are, invited by me to do so. And yeah, that's all.